In this video, we'll do an example or two with linear inequalities. So our ambitions here are modest. We have discussed how the multiplication property of inequalities frequently stops you from solving them, or at least it makes it a lot harder. A linear inequality is when you have one linear expression less than or equal to or greater than some other linear expression. And these we can solve just using the rules for manipulating inequalities that we have already seen. So we've been doing less than a lot. Let's have greater than or equal to this time around. And let's solve this inequality. And there are a few ways we can do this in terms of the precise steps that we follow. But whatever steps we follow, our goals are going to be basically the same. We want to combine these constants, and we want to combine these x's. So maybe we decide that we're going to add 7 to both sides of this inequality. We can certainly do that. We can add or subtract the same thing to both sides. It doesn't matter whether it's positive or negative. 2x is greater than or equal to 3x plus 8. And now we want to combine these via subtraction. Maybe we subtract that 3x over. And because x is a variable, we don't know whether 3x is positive or negative. But for subtraction, that doesn't matter. It's only multiplication or division where that comes into play. And now we can multiply both sides of this inequality by -1 and greater than or equal to becomes less than or equal to, because you have multiplied by a negative number. In reference to what I said about, there being different steps you could perform, maybe at the start of this problem, instead of deciding to take this 7 over here, we decide to take this 1 over here. Let me just copy this down real quick. And now let's take this 1 over to the right over to the left via subtraction. And now we could bring this 3x over here. Maybe it would make more sense, though, to take this 2x over here via subtraction. So it doesn't matter whether x is positive or negative. And in fact, we're now done. X is less than or equal to -8. And of course, we ended up getting the same interval as long as the steps you perform are correct, as long as you don't just flat out make an algebraic error, you'll wind up in the same place eventually, no matter which side you take the constants over to, or which sides you take the x's over to.